FTK Imager is a free open-source data preview and imaging software used for digital forensics. FTK Imager allows the user to copy image files of devices in order to examine the data without making changes to the original evidence. This is important for both data preservation and chain of custody reasons in an investigation. FTK Imager provides a hashing function that is designed to provide an integrity check to verify that the original data has not been tampered with during the investigation. FTK Imager can be used to conduct various forensics functions such as creating a hard disk image file, capture memory, analyze images, and decrypt encrypted data. Downloading FTK Imager. First, go to the website accessdata.com and then hover over the Products and Services tab on the top menu bar. Click the tab that says FTK Imager, then select the button that says Download FTK Imager. From here, you will need to scroll to the bottom of the page and fill out a short form and then submit the form. After pressing Submit, the download will automatically begin. Using FTK Imager. Open the software and you should be able to see the main screen that looks like this. Click File and then select the option to Create Disk Image. A pop-up will ask you to select the source of the drive you are creating. If it is a physical device, then choose Physical Drive. If it is a partition on a drive, then choose Logical Drive. Or you can select any of the other options if you are imaging a different source. For most cases, we will be using either a physical or logical drive. From here, you will select the location of the drive you are creating an image file of. A list of available drives will be available on the drop-down menu. Then you will select the destination location of the disk image that you are creating. Then press Add and select the type of disk image you want to create. For this presentation, we will choose RAW DD, which is a bit-by-bit copy of the drive and is the most common. Next, you will enter the case information about the disk image. Next, you will enter the actual destination where you want the disk image file. Enter 1500 into the image fragment size and then click Finish. Next, you will see the radio button that says Verify Images after they are created. This is an important step as it creates a hash which can be used to check the integrity of the file. Once this is selected, you can click Start. Depending on the size of the drive, it will take a few moments for this process to complete. When finished, a screen will appear that shows the image file hash digests. Under Verify Result, you can see whether or not the hash files are a match and will be under the MDF and SHA-1 hash results. This allows you to know that your image file has been created successfully without any issues during replication. If you open the destination file that you configured earlier, you will find a text file that contains important information about the image file. It will show you what version of FTK image was used, the case information, and the checksums for the computed hashes. This information will be very useful for chain of custody purposes later on if you are working on a law enforcement investigation. Mounting an image. In the top left screen, under the File tab, click the option that says Image Mounting. Then, when the pop-up appears, click the option to search for the file location on the right side of the search bar. Find the image file that you just created and select the first file of the batch in the folder. Under the Mount method, select Read Only so that the image file is not changeable during the investigative process. In order to see the contents of the image file, you now need to add it to FTK Imager. You do this by selecting Add Evidence Item in the top left corner of the screen. Because you have now mounted the drive and you want to select the copied image file, you will choose Logical Drive. Then you will select the new mounted drive that you just created and click Finish. You will now see that the drive is visible in the top left corner of FTK Imager. You can start opening and examining files by clicking on each file and then exploring the subfolders in each one. Now that the image file is uploaded onto FTK Imager, you can begin to conduct an extensive examination of the drive contents. Capture memory. In digital forensics, it is important to understand the volatile nature of certain types of memory. When investigating a drive, you will want to be sure to follow the order of volatility, which essentially states that data should be collected in the order of most volatile to most stable. This way, volatile memory that may be lost in a short period of time will be captured first, and then the investigator can move on to more stable forms of memory. An example of this would be capturing random access memory before attempting to collect archive files on a drive. To capture memory on a drive, first you will want to click the File tab on the toolbar. Then select Capture Memory. From here, you will be given the option to choose the destination path of the data. Once this is done, select Capture. This process will take a variable length of time, depending on the size of data being captured. View Recycle Bin data. The Recycle Bin is a folder in Windows that is reserved for deleted files. Many times, these files are not permanently deleted and can be recovered during the digital forensics process. This section will show you how to view the contents of the Recycle Bin on the drive that you are examining. First, on the left toolbar, select Windows NTFS or something similar depending on the drive type and version. Then select Root, and just under this folder you should see Recycle Bin, usually in all caps. Once you click on the folder, you will notice that a file viewer is opened on the right side of the screen. This will show the associated folders for each user of the information system. Click on one of the users and then you will be able to see the contents of their recycle bin. From here, you will be able to select each individual item and examine its contents. You may notice that there are duplicates of each file. This is normal as one file is the actual file and the other is the file's metadata. View Embedded Thumbnail Images. Thumbnails are tiny images that are embedded into various file types and can easily be recovered using FTK Imager. A lot of information can be provided in an image that can help the investigator determine what type of activity the user of the information system was engaged in. In order to do this, you will need what's called a thumb cache viewer, which will need to be downloaded from an external source. There are many thumb cache viewers available, so any of them will work as long as they are compatible with your operating system. You can download the one used in this presentation by clicking the link on this slide, thumbcacheviewer.github.io. Once you've downloaded the viewer, you can return to FTK Imager and begin extracting thumbnail images. Under Windows, you will find a folder called Root. Click that and then find and click Users. From here, you will need to click on a username and then select App Data, then Local, then Microsoft, then click Windows, and then select the Explorer folder. From here, you will see a list of icon caches and thumb caches located on the right side of the screen. When you load them into the thumb cache viewer, you will then be able to see the image and use it for further examination. System Resource Usage Manager, SRUM. The SRUM is a very important resource for digital forensics as it can show valuable data about which applications were used, where, and how they were used. This can include various information on general applications, network connectivity data, energy usage, and notifications. For example, with this resource, you will be able to determine which internet networks the device has historically connected to, which can be used to place a certain individual at a certain location and time, which is highly useful in an investigation. First, you will need to go to this folder, then click System32, then SRU, and then click this file. The information will need to be extracted and then exported into an Excel spreadsheet to view the data. From here, you will be able to investigate the fine details of such as those mentioned above. On the left side, you will see the application data, which shows you the application and its location. As you move further to the right side of the spreadsheet, you will notice various different tabs and their corresponding information below. The username will clearly show what user was using the computer, what application they were using, and for how long. By selecting the Network tab at the bottom of the spreadsheet, you will then be able to examine the network data associated with the device as mentioned earlier. This will show the connection start time, usage time, connection type, and the SSID. As you can see by now, FTK Imager is a highly useful tool for digital forensics. Its easy to navigate graphical user interface and feature-rich selection makes it a great choice for both beginners and advanced professionals in the field. Although FTK Imager cannot do everything in a digital forensics environment, it should be a tool that is regularly used by anyone in this industry. There are many third-party features that can be added to FTK Imager that make it even more useful. As you learn how to use the software, you can begin to explore some of the more advanced options that are available.
I am Big Sam, a digital forensic analyst, ethical hacker, security researcher, tutor, and speaker. Thank you for watching this video.